Okay, now I'm going to start this lecture. In previous lecture, we had discussed about Rashmi. In previous lecture, we had discussed about introduction. Okay, in introduction, we had seen the different manufacturing processes, starting process, forming process, continuous process, and different types of manufacturing methods are there. We have seen different types of manufacturing processes, that is job shop production, batch production, continuous production. Now, today I'm going to start this new chapter, that is milling machine. Okay, so milling machine is a machine in which you can remove the unwanted material, you can remove the metal from the surface of your workpiece. Okay, means what type of surface uh, will be machined. This milling machine. Just switch off your microphone, all of you. Now screen is visible to all of you.
Yes,
Yes,
sir.
sir.
आपकी नहीं दिख रही।
Yes, sir.
Now
सर रिमूव होके फिर अंदर आया तो भी नहीं दिख रही।
इसे ट्राई करो। आपको दिख रही है, आपका ही प्रॉब्लम है, तो नेटवर्क का प्रॉब्लम होगा शायद।
सॉरी सर।
Select lecture. Okay.
Start, sir.
Okay. Milling machine is a machine through which you can remove the metal from a workpiece like a flat job. Okay, as you know that the in our workshop there are different types of machine is there, and all that machine are known as conventional machine. Suppose lathe machine, milling machine, drilling machine, shaping machine, broaching machine. Okay, all such type of machine are generally categorized into the conventional machine. Okay, there are two types of machine is there, conventional machine and non-conventional machines. Generally, if some machines that are regularly or repeatedly used since a while, then that type of machine are known as conventional machine. And the example of conventional machines are lathe machine, milling machine, shaping machine, broaching machine, and so on. Okay, so in our manufacturing process subject, uh, there is dedicated chapter on milling machine, and in this chapter, there are the different types, means classification of milling machine, operations, and indexing of milling machines are there. So, milling is a machine tool in which metal is removed by means of revolving multi-point cutter. Okay, so in milling machine, what happened? Milling machine having a two type basically, vertical milling machine and horizontal milling machine, and that is depends on the shaft. If shaft is located on the horizontal direction, that is called horizontal milling machine, and if the shaft is placed in a vertical axis, so it is known as vertical milling machine. So basically it can be categorized in these two way. You can identify the machine in these two very brief sense. Horizontal, if the axis is placed in a horizontal directions, and if your axis of the cutter or axis of the spindle is placed and on the vertical axis, then it is known as vertical milling machine. and the work is fed to the cutter longitudinally, transversely, or vertically. So in milling machine, generally your cutter will be revolved with a different speed, and that speed can be achieved by different gears. Okay, you can change the speed of milling machines through the your lever. Okay, and that cutter will be mounted on the spindle. On the spindle there is a arbor, and on the arbor there is a cutter, and cutter will be rotated at the different speed, and your workpiece will be fed down against your multi-point cutter that is revolving. So your cutter will be revolving and your workpiece will fed in the longitudinal directions, transverse directions, or vertically up and down. So your workpiece can be fed in any of the directions against your revolving multi-point cutter. And once the cutter and your workpiece will met, then due to the revolving motion of multi-point cutter and the longitudinally or transverse movement of your workpiece, then unwanted metal will be removed from the flat portion of the workpiece. So generally keep in your mind, in milling machines, flat type of workpiece can be machined. While in lathe machine, what happen? In lathe machine, cylindrical type of workpiece can be machined. If your workpiece is cylindrical, then you have to machine that workpiece into the machine, that is lathe machine. And if your machine, your workpiece is supposed to flat, means that type of workpiece can be machined with help of milling machine. Suppose if you want to differentiate lathe machine and milling machine, then in lathe machine your workpiece can be fitted into the chuck, and that workpiece can be revolved. While in milling machine, cutting tool that is known as multi-point cutter that is fitted on the arbor, and arbor is fitted in the spindle. So ultimately your cutter will be revolving, while in lathe machine your workpiece will be revolving. In lathe machine your workpiece is revolving and the cutter will fed down against your workpiece, means cutting tool will fed down against your workpiece. So you can say that work in lathe machine, workpiece is revolving and tool is stationary. And in milling machines, you can say that the tool is revolving and your workpiece is stationary. Okay, and both the machine is conventional machine. But in lathe machine, cylindrical workpiece can be machined, while in milling machines, flat type of workpiece can be machined. And in milling machine, generally different types of cutting tool are used. Now, the work is fed to the cutter longitudinally, transversely, or vertically, so that you can remove the remove the material in any of the direction from the workpiece, because of three different directions in which you can fed your workpiece toward your multi-point revolving cutter. Here, why it is called multi-point cutter? Because the cutter used in milling machines are having the number of cutting point. That's why it is called multi-point cutter, because it is having multi points through which your metal will be removed. In lathe machine, the tool name is single point cutting tool, because the tool having the only single point through which your metal will be removed. That's why it is generally known as single point cutting tool that is used in lathe machine. While in milling machine, the cutter used uh, is having a more than 2 point through which your metal will be removed, so that that cutter is generally known as multi-point cutter, and that cutter is placed or cutter is mounted on arbor, and arbor is mounted on the spindle, and that spindle will be rotated at the different speed, and your workpiece will be fed against the tool, and once both will meet, then due to the relative motions means revolving the cutter, and your job will fed against the tool. So between this relative motion of the tool and workpiece, your unwanted metal will be removed from the flat surfaces, and then you can convert your raw material into the finished product. So lathe and milling machines are general purpose machine. Here in these lectures there are two different word comes arrived, that is general purpose machines and conventional machine. Okay, so general purpose machine is what? General purpose machine is the machines that can be regularly or that machines used for regular operations, means regular cutting any from the any raw material can be cut with help of this type of machines. That's why it is called general purpose machines. Now the depth of cut is set by raising the table to the certain height, and metal is removed by sliding the table holding the workpiece. Now as I told you that multi-point cutter can be mounted on the arbor, and workpiece can be mounted on the table. Okay, so table can be moved in any of the direction. So once you move up and down of the table, through this up and down movement of the table, you can decide the depth of cut. Okay, if you raise the table by the 1 mm, then your depth of cut is 1 mm, means 1 mm metal will be removed from your workpiece. If you raise your table towards the tool to 0.5 mm, then your depth of cut is 0.5 mm. Got it? So depth of cut is nothing but a parameter through which your metal will be removed. So depth of cut is a numerical value. Okay, and that can be set by up and down motion of the table. So the depth of cut is set by raising the table to the certain height as per your requirement, and the metal is removed by sliding the table that holding the workpiece. Suitable means milling machine is suitable for the tool room work due to its variety of operation with better surface finish and accuracy. Here, new word tool room. Tool room is a a room or a field in which various types of operation can be performed, or a number of machines can be developed. So in that tool room, variety of operations could be performed, and that all the variety of operations could be possible with the help of milling machine. The milling machine available as vertical and horizontal type, as I told you before 2 or 3 minutes, that generally you can classify the milling machines in a two way. It could be vertical milling machines or horizontal milling machines. If the axis or the spindle of the machine is placed or held and the on the vertical directions, so it is called vertical milling machines. And if the spindle orientation in the horizontal directions, so it is known as horizontal milling machine. Several complex milling can be done using jigs and fixtures. Now jigs and fixture is what? Jigs and fixtures are work and tool holding devices. So through the device you can hold the workpiece or the tool. Okay, so by using jigs or fixtures you can hold your workpiece, and that jigs or fixtures can be mounted on the table. Now see on the screen there are the different parts made by milling machines. See in the figure A, B, C, D, and E type. Okay, so that is nothing but a parts manufactured or created with help of milling machines. So from this figure, you can easily uh, understand that the generally flat type of parts can be manufactured with the help of these machines. Generally, okay. Generally, this type of parts can be manufactured. In sometimes cylindrical parts may be produced, but generally and most of flat type of surface can be produced with help of these machines. That's you can see in this screen on the screen. Now, as I told you, the machine can be divided into two categories. That is horizontal milling machine and vertical milling machine. Am I audible to everybody?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine, fine. In this figure, in this screen, there are two type of machines. Generally, you can categorize the milling machine in two type: horizontal milling machine and vertical milling machine. So first one is called horizontal milling machines because the orientation of the spindle is in the horizontal directions. So spindle orientation is horizontal. That's why the first machine is called horizontal milling machine. And see the arbor. This arbor is fitted on the spindle. Okay, your spindle is hollow so that you can fix your arbor and having the taper, and the taper can be attached to the spindle part. So arbor can be fitted into the spindle. So this is spindle. As you see, there is a arbor. In first machine, arbor is there. So arbor can be inserted into the spindle, and one part can be fitted on the overarm. Okay, this is the overarm. See in this figure, first figure, horizontal milling machines, overarm is there. So one end of the arbor is inserted into the spindle, and another end of the arbor can be fitted on the arbor yoke. Okay, and multi-point tool that is fixed or mounted on the arbor by the spacers. Okay, you can adjust the distance or of the multi-point tool on the arbor by the spacer or washers and fix by the overarm. Okay, so your cutting tool will be fitted on the arbor, and arbor is fitted on the spindle, so that can be rotate or revolve at the different speed. And see here there is a table. Okay, so the table can be moved in any of the direction. Means it can be moved longitudinal directions, it can be moved transverse directions, or it can be moved up and down. So in any directions it can be moved. So with help of this movement, horizontal means longitude, sorry, so with help of this movement, longitudinal movement, transverse movement, and up and down movement, you can mesh your workpiece, or you can just create a meshing of the workpiece with the tool. And due to this meshing, or due to this relative motion of tool or single multi-point cutting tool and workpiece, your unwanted materials on the surface of workpiece will be removed. Okay, so in first figure, you can observe that there are different part of milling machines. First is overarm. On the top, there is a overarm, then arbor, then column, then workpiece, and workpiece is mounted on the table, then saddle, and saddle is mounted on knee, and below the knee there is a elevating screw, and at the bottom side there is a base. Okay, so these are some part of milling machines. On the another side, in second figure, the machine is known as vertical milling machine. So as I told you that if the orientation of the spindle is horizontal, then it is called horizontal milling machine. And if the spindle orientation in the vertical directions, then it is known as vertical milling machine. So second one, in second figure, the spindle orientation in the vertical directions. That's why it is known as vertical milling machine. Here also the different parts are there: head, column, spindle, work table, workpiece, saddle, knee, and base. Okay. So up till now, if you have any doubt, then please ask me. If you have
Sir,
any doubt,
this
yes, please tell me.
सर ये सैडल है, ये पार्ट के बारे में थोड़ा बताइए.
हाँ
What
हाँ
is this saddle?
definitely. Anybody else? Anybody else? Okay. See, saddle is what? Through the saddle means saddle is a part which is mounted on the knee, and on the saddle there is a part that is called work table. So work table is mounted on the saddle, saddle is mounted on the knee, and knee is mounted and slide over the elevating screw. So saddle, and through the saddle and knee, your table movement can be possible. Got it? So through the
So we
saddle,
can take this.
you can move your table in a transverse direction. Through the knee, you can move your workpiece in the up and down directions. And through the table, it can be mount on the longitudinal directions. Means with help of this saddle and knee, your workpiece or your table can be moved in longitudinal, transverse, and up and down movement. Okay, it is a mechanism. Saddle and knee is a mechanism or a part, you can say that, and through which your table can be moved in different direction. Got it?
Yes, sir. Which means saddle has having the guide weight.
Yes.
Yes. Okay.
That is, and there is a some mechanism like a pinion
Rack and pinion, maybe. Rack and pinion.
mechanism are there, or some lead screw are there. So through that screw and nut mechanism, your workpiece or your table can be moved in transverse direction. Okay. As in this figure, you can
Yes.
also see that there is a some lead screw type mechanism. So if you rotate the handle in this figure, there is a missing of handle. Here there is a handle, and through that, if you rotate that handle, then your table can be moved transversely. Got it?
Yes, sir. Got it.
Don't worry, this is the first lecture, so I am giving you a brief idea. Okay.
Okay,
The
sir.
next lecture onwards, we will I will just definitely show you different parts with the exact image and video also. Okay, so don't worry, this is a first lecture, so just you grab the uh, just definition and some major parts of milling machine. Okay, I will definitely go through the parts in the detail in the next lecture. Okay. Now
Yes.
see, uh, these are the different image of vertical and horizontal milling machines, in which you can clearly see the elevating screw. horizontal milling machine માં જુઓ, in horizontal milling machines, table is mounted on the saddle, saddle is mounted on the knee, and knee is mounted on the elevating screw. It's vertical screw દેખાશે તમને. That's with help of that screw, that knee can be moved up and down. Through the saddle, the movement of the saddle, knee ની ઉપર શું છે? saddle છે. So through the saddle, your table can be moved in transverse directions, and on the saddle there is a table. So table can be moved in longitudinal directions. So with help of these combined mechanisms, your workpiece can be moved longitudinally, transversely, and up and down. Got it? This
Yes,
is
sir.
different type of milling machine. Now, principal parts of milling machine. So as I told you, the base, column, knee, elevating screw, overarm, arbor, table, saddle, knee, and base are the principal part of milling machine. So one by one, I will just go through it. So first is base. So base is what? It is the foundation of the machine upon which all the other parts are mounted. Okay, so base is the foundations on which all the other parts are mounted. So due to this, your base must be strengthened, or it should be a heavy as well as it should be a made from a material like a shock absorber. If that absorb the vibration and shock, then it will be a stable. Okay, that's why it is made, generally bases are made from gray cast iron. That's why it will absorb the shocks and vibrations. Generally, if you look into all the machines, or if you observed the different machines, so machine beds are generally bed and base are generally made from cast iron, because the characteristic of cast iron is to absorb the shock and vibrations. And if you reduce the shock and vibrations on the machines, then it will be stable. If there is a no vibration, then you can remove the material with a better accuracy. That's why if you observe the in general machines, the bed and base of most of the machines are made from cast iron, because the characteristics of cast iron is to absorb the shock and vibration. In addition of these two, base is hollow part. It is a heavy, made from cast iron, and it is a hollow part. Inside it there is a cavity, means it is a hollow. Why it is hollow? Because inside the base there is a lubrication. Okay, it is filled up with the lubricating oil, and that lubricating oil can be moved into the workpiece and cutter part. Means it will be transferred to the portion at which machining are carried out, and due to this cutting fluid, your machining can be easily done. Because what happened in the machining, if the machining is done at that time, due to the mashing of your revolving workpiece, revolving cutter and workpiece, very high temperature can be generated. Okay, so to set the temperature at some certain level, you must have to sprinkle, or you must have to spray the cutting fluid, and that cutting fluid is filled up in the base, because base is hollow part. So from base, it is just transferred to the place where machining is carried out through some pump. Got it? And again, after machining, it is collected in the table, and through a small pipe, it is again accumulated or transferred to the base. So it is a circulated from machining. It can be transferred to the base, and again from the base it can be transferred to the machining area through some pipe or pump mechanism. Okay, so base is the most important and a very a critical part of the milling machines, and it can be made from the grey cast iron. Second part is column. As I told you, base is a hollow part. Now another part is column. Column is also hollow part because inside the column there is a different types of wiring and motor mechanism are there. Some gears are there. Okay, so all such mechanism inside the column. Okay, so it is the main supporting frame mounted vertically on one side of the base. Okay, so as you know that base is there. So on the one side of the base, this column is mounted. And I told you that the motor and other driving mechanism are contained in it. So base is hollow part, column is also hollow part. That's why some motor and other driving mechanism can be placed inside it. It supports and guides the knee in vertical travel. Okay, so on the one face or front face of the column, there are the guideways, and that guideway will support the knee. So that knee can be easily move up and down motion with these guideways. Okay, and that guideways are created or generated on the front face of the column. Next part is knee. So knee is what? It is a projected, it projects from column and slides up and down on its face. Okay, so knee is what? Knee is mounted on the elevating screw, and on the front side of the column it can be moves up and down through the guideways. So it projects from column and slides up and down on its face. It supports the saddle and tables. As I told you in the previous figures and slides, in that image, if you observe, table can be mounted on the knee. Okay, so first of all, base. On the base there is an elevating screw. On the elevating screw there are knee. On the knee, saddle. On the saddle there is a table. Okay, so base, elevating screw, then knee, then saddle and table. This type of arrangement are there. Its height can be adjusted by elevating screw. So if you want to rise the height of knee, if you want to lower or upper side movement of the knee, then that can be adjusted with the help of elevating screw. It carries feed control mechanism and controls feed in longitudinal, cross, vertical by hand power or machine power. Okay, so with help of this knee, all such feed control mechanism and control feed in any of the directions, means longitudinal, cross or vertical, and that can be possible with help of hand, as well as you can automate that all these directions with help of machine power. And the next part is saddle. So saddle is, as I told you, that saddle is mounted on the knee. So it supports and carries table and is adjustable transversely. It is used to cut off the metal after positioning. Next is table. Just in today lecture, don't worry, if you don't grab any of the point, I will definitely repeat these lectures into or this lecture into video lectures. Okay, or some videos I will just definitely see some videos through which your idea can be cleared. Okay, so don't worry, just today just listen this lecture and try to get knowledge from this lecture. Okay, now next one is table. So table resets on the ways on the saddle and supports the workpiece, fixtures, etc. Your workpiece is also mounted on the table and workpiece is mounted on the fixture. Okay. Suppose the heavy workpieces are there. So that heavy workpiece are mounted on the fixture, and that fixtures can be mounted on the table. Next is overarm. As in the you observed in the figure of the first or second slide, that overarm is there on the top side of the machine. The overarm is there. So overarm is what? It is mounted and guided by the top of the column. Means one side of the column is mounted on the base, and on the top side of the column the overarm is there. So overarm is mounted on the top portion of the column. It carries arbor that hold the cutter. Okay, so this overarm carries arbor, and arbor, on the arbor your cutter can be mounted, and arbor can be inserted into the spindle. Now next is arbor. So it is extension of spindle on which all the various cutters are mounted. You can mount one cutter, two cutter, three cutter. Number of cutters can be mounted on the arbor simultaneously, and simultaneously that number of cutter can be remove the metal. Okay, if one cutter is there, that can also able to remove the metal. If two cutter is there, that can cut the materials. If three cutter simultaneously mounted on the arbor, then that three cutter can also be remove the material simultaneously. Okay, so you can mount number of cutter on the arbor depending on your requirement. So it is the extension of the spindle on which all the various cutters are mounted. And as I told you that the one part means one end of the arbor is tapered. So it is tapered at one end to fit spindle nose and has a slot to fit the keys of cutter. Means that taper portion of the arbor can be inserted into the spindle hollow taper portion, and one key slot are there, so that key slot can be adjusted to fit this arbor, and another end of arbor is fitted into the overarm. Clear? So in these lectures I am just stop these lectures because in next lecture I will definitely we will discuss this detailing of milling machines with help of some videos and images also. Okay, just a minute.